Hi, I'm Miranda Cosgrove, and this is Mission Unstoppable.
Coming up, let's hear it for Hollywood. We'll show you the science behind the sound in all your favorite shows. Then, I'm gonna spill the STEM tea on the secrets of the universe with a little help from the James Webb Telescope. Next, how a fungus could feed the world and make you an awesome BLT. And all aboard the science train as Electric Cat shows us how magnets can really move.
Like that.
Get ready to meet the scientists, inventors, and heroes who help make our world a better place. The future is here. The mission, unstoppable.
If you're making a movie and you need the sound of a spaceship crashing, you can't just go out and blow one up. NASA would be so mad. No, you need a Foley artist. We sent Fig to find out how Sanaa Kelley uses science to bring sound to life.
That was weird. Okay, that was a strange sound. Hey. Whoa. Okay, something weird is going on with the sound, and I think we need to talk to an expert.
An expert called a Foley artist. They're the ones who synchronize the correct sound to match the action in film, TV, and video games. And one of Hollywood's best Foley artists is Sanaa Kelley. Among the many projects she's worked on are Ted Lasso, High School Musical: The Musical, and Riverdale.
I always loved science, ever since I was like a little girl. I went to Medical Magnet High School, got my biology degree, went to med school, but I guess Foley just kept pulling me towards it, you know, but I still get to use science every day in my life, so I guess I'm one of the lucky ones.
So this is your studio.
This is my playground.
Wow, I don't even know where to look first. There is so much stuff in here. There is some sort of pit behind you?
So this is the dirt pit, and then that's the water pit where all the swimming and stuff happens, and that's the splash pit.
Soaked.
Different types of mics are used to capture a range of sounds like this shotgun mic. It's called a directional mic, and it's great for picking up sounds right in front of it. After it's in place, Sanaa shows me how she works in her playground.
So I'm watching the screen, one of my 3 screens, and I'll just do the footstep of the actor walking as they're walking. If I can't see their feet, I'll watch their shoulders. If they walk on gravel, I'll walk on gravel. I have this 1/2-inch tape, which I use for like deep grass if they're in the forest.
Whoa.
Kind of close your eyes and listen.
Yeah, that does sound like you're wading through kind of tall grass.
So the fun one that people can't guess is snow. They always ask, what do you use for snow? But the easiest way to use snow is you get a nice pillowcase.
Uh-huh.
And you put some cornstarch in there.
That's so cool.
Yeah, so then
Wow.
that's really cool. Now, if you have fluffy snow, you could actually put it with sand or some grass seeds in a pillowcase. Okay, well, enough of me talking about Foley. Let's get you in some action. So just remember.
Sanaa walks me through how she studies a scene, taking note of the different floor surfaces and the type of shoes being worn. It turns out this is a science job that comes with a suitcase full of shoes. Where do I apply? Now it's my chance to be in the movies. Well, not in the movies, but making sounds for the movies.
I almost had it.
That was so hard.
It's harder than it looks. It takes a couple of tries before I can match the actor's footsteps.
Oh my gosh, that was awesome. That was so good. Seriously.
That was a lot of fun.
Wow, you're really good.
Now that I've mastered footsteps, Sanaa cooks up something else for me to try. The sound of boiling pasta. And the trade secret behind the sound? A car chamois. And little Swiss cheese-like sponges swooshed around in a pot of water. The sound waves bounce around inside the sponges, much like it would bounce around cooking pasta.
That was excellent. You would have ruined your take with your laugh at the end. That was good.
I think I was pretty good with stopping and starting.
You were really good.
Thank you so much, Sanaa, for showing me what it's like for you to be a Foley artist. I had no idea that there's so much science that goes into being able to create all the sounds that you do. High five? Ah, yes, that's what that's supposed to sound like.
We've come a long way from when Galileo first turned his telescope to the stars back in 1609. In 2022, NASA deployed the most advanced telescope to ever exist. It's called the James Webb Space Telescope, and it's designed to let us look back 13 billion years in the past. So today, we're spilling the universe's oldest STEM tea. The James Webb Telescope launched on December 25th, 2021, and it took 1 month to make its 1 million-mile trip to its new home, L2. So when someone asks you how far would you go for science, the correct answer is 1 million miles. L2 is the second Sun-Earth Lagrange point, or a gravitationally stable location in space. This specific spot will allow the telescope to stay in line with Earth as it orbits the Sun. But this is no normal telescope. It's the most powerful space telescope ever, and it took 30 years to build it. It's as tall as a 3-story building and as long as a tennis court. But that's not the coolest part. The telescope's mirrors have a thin layer of gold that helps the mirrors reflect infrared light. Sorry for people with silver-tier telescopes. Webb wins again. That infrared light is invisible to the human eye, but not to the telescope, which uses its infrared cameras to see through space dust. This lets it see the stars and planets inside those dust clouds clearer than ever before. So how are they able to get something so big up into space? Well, scientists fit the telescope inside the rocket by creating an origami-style fold for the telescope that took 2 weeks to un-origami itself. It'd be cool if it looked like a paper swan, but NASA probably just made it functional. So what's one thing you do when you get to space? Take a selfie, of course. Here it is, checking to see that the honeycomb mirrors are aligned correctly. Even though the Webb telescope is a star to me, the real purpose isn't selfies, but pictures of the universe. One of the most remarkable early photos from the James Webb Telescope was this deep field photo, where the telescope looked at the same tiny spot in the sky for 12 hours. To get an idea of how tiny the spot is, imagine holding up a single little grain of sand at arm's length so it's itty-bitty. There are only a few stars in the deep field photo. Almost every dot is an entire galaxy. So we're looking at literally thousands of galaxies, each with many billions of stars, many billions of light years away from each other. Part of what makes this incredible deep field photo possible is in the middle of the image, a supermassive cluster of galaxies called SMACS 0723. Multiple galaxies filled with black holes and planets and hundreds of billions of stars means that this cluster has a lot of mass, like a lot of mass. And more mass means more gravity. And that gravity can be used for something called gravitational lensing. You see, gravity doesn't just pull on things like planets and asteroids. It warps everything around it, even light. With something as massive as this galaxy cluster, gravity can bend light like a giant superpowered natural lens, magnifying light from the other side of the cluster and giving us a peek at galaxies from the early days of the universe. These ancient galaxies can tell us about what the universe looked like in the first billion years' time. And the Webb telescope may have already captured the oldest galaxy ever seen, born only 300 million years after the Big Bang. Using spectroscopy, the telescope should be able to tell us what elements provided the building blocks of the early universe, and give us insight into how those early galaxies formed. We'll also get our closest views ever of stars being born and even dying. But we're not just studying galaxies. The Webb telescope is also searching for extraterrestrial life. Scientists plan on studying exoplanets right in our own Milky Way, scanning the atmosphere to see if there are any Earth-like planets that could harbor life. We've already seen so much in the short amount of time it's been in space, and this is just the beginning. I can't wait to see what else they discover in the next few years. Could you imagine discovering an Earth-like planet full of life? I wonder if there'd be an alien version of me there, talking about their version of the Webb Telescope. If you're out there, Space Miranda, I want you to know I will destroy you. There's only room for one of us in this vast, 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 vast universe. This next guest knows a ton about science. I don't know if that's a metric or imperial ton, but I'm sure it's a lot. Check it out.
I don't know if you can tell, but I am very into celebrity food trends. I mean, Dwayne "The Rock" Johnson and I pretty much have the same eating habits. But one fashionable food choice I'm really excited about is meatless meat. And while most of those options are plant-based, one innovator has found a protein alternative in the form of fungus? Yeah, let's check it out. That innovator is Kimberly Lee, who works in the growing field of culinology, where culinary arts meets food science.
My mom's a chef, so I grew up in kitchens, and I absolutely love food. I went to college and I studied microbiology, and so I'm able to combine my love for food and a little bit of science and microbes in there as well. As a meat eater myself, even today, I want to do better by the planet, but I don't want to compromise because meat tastes delicious.
Today, I'm visiting Kimberly to see how she's breaking the mold with a new meat alternative.
Welcome to our deli.
So I hear that you're making meat out of fungi?
Mm-hmm.
How does that work?
We use koji, which is the ingredient in miso and soy sauce that makes it really umami and delicious. And it is a fungi. It comes from Japan, and we've been eating it for over 10,000 years.
Kimberly explains that there are numerous reasons to explore meat alternatives, including how animal agriculture uses a lot of energy and resources. It takes more crop calories to feed a cow versus the amount of calories the cow's meat produces. With fungi, that ratio is closer to a 1-to-1 efficiency.
As it stands, we'll need 8 planet Earths to be able to sustain our love of meat, and we just don't have 8 planets.
So are you trying to completely replace meat?
No, we're trying to be a part of the solution to being able to feed the growing population.
Cool, I'm excited to try it.
Of course, would love to show you how the sausage is made.
There's a lot of stuff on this table. So what is all this stuff?
This is koji.
This is koji?
That is.
How did you stumble upon this fungi?
Koji is part of a lot of chefs' culinary toolkits. A lot of the best chefs in the world use koji to ferment a variety of products. It really enhances the flavor of foods. And what we found is it also has the natural texture of meat.
So why is the koji in what appears to be water? Kimberly tells me the water is actually full of nutrients, which are just sugars the fungi feeds on to grow and replicate.
So koji grows in this really, really fibrous texture. You can see it's kind of floating here. This texture is actually identical microscopically to meat under a microscope. That translates into a texture that actually feels meaty when you bite into it.
It's this ability to mimic mouthfeel, like the chewiness of a juicy steak or the crunchiness of crispy bacon, the sensations meat eaters don't want to give up, that Kimberly believes sets koji's texture a cut above the rest. So something smells amazing.
Bacon time.
Being the fun guy that I am, cheers. You know I'm all for tasting it. Oh my goodness, this is delicious. Like, I'm not even just saying that. This is really good. It's amazing to me that that little white cloud you showed me in that jar earlier grew up to be something that resembles meat.
There's no animal in that whatsoever.
I mean, that's bonkers to me.
That's the magic of koji.
Kim, thank you so much for teaching me about protein structures and introducing me to koji. This was all really cool. I really appreciate it.
Thanks for stopping by. It was great to show you how the meat is made, and it was lovely to meet you.
Oh, that was really good.
Thanks, Nabil.
Bye.
Bye.
What's better than one science? 2 sciences. Or 3. Or like 5. That would be amazing. We just have one right now, though. Check it out.
What do you get if you combine a battery, some magnets, and a coil of copper wire? Today, I'm gonna show you how magnetic fields power the world's tiniest electric train, just big enough for a caterpillar-sized businesswoman to use on her office commute. Hi, I'm Electric Cat. Are you ready to see something really cool? So how do we make our train? First, we take copper wire and wrap it around a dowel of some kind. You can even use a broom or anything that looks like this that you may have lying around your house. You want the coils to be just bigger than the size of your battery and close together, but not overlapping, like this. This can take a while, so we did one of these earlier. It should look like a robot snake, especially if you give it some googly eyes and a tongue. Next, we'll put the magnets on either side of the battery. How they're attached is very important. You may remember that magnets have both a north pole and a south pole. Similar poles repel each other, and opposite poles attract each other. Same pole repel, opposite pole attract. Like that. The magnets on our train need to have like poles facing in opposite directions, with the other pole sides attached to the battery. Since these sides are repelling, I will be attaching them like that. We're using a special kind of magnet called neodymium magnets. What makes these magnets special is that they can conduct electricity. Thus, when the neodymium magnets are attached to either end of the battery and they touch copper wire, a circuit is made along the length of the battery. Electrons will flow out of the negative side of the battery into the magnets, through the wire, and back into the magnets on the positive side of the battery. But electrons moving through a wire do something pretty incredible. They produce a magnetic field. This field becomes strong enough to repel the magnets on one end and pull the magnets in the other. And so the train moves through the coiled wire. The magnetic field moves as the train moves, keeping up the momentum. The same science is used to power everything from the engines of electric cars to the fan in your hairdryer to your dentist's drill. But it's a lot cuter when it's a tiny little train, right? Let's use this power to make a little battery go zoom. Are you ready for this? This is so fun. And there it goes. Let's do it again. Ooh. That's all from me. I've got a train to catch. See you next time.
Welcome back. Before we go, we have one last thing.
If I have one piece of advice for women that want to do this, do not take no for an answer. Just keep trying, and you'll get it.
There are so many different fields of study within STEM. I recommend taking a class here or there or reading on the internet about all the different STEM options and get inspired.
It is hard, and that is okay. When I was growing up, I heard so many times that if you're not good at math, you're not good at science, then you shouldn't try to pursue a career in STEM. And that is not true. It is hard for everyone. And actually, it being hard can be the reason why you like it.
That's it for Mission Unstoppable. I'm Miranda Cosgrove. Tune in next time when we see if moths like all sweaters or if we can get them to just eat the ugly ones. Bye. If you're watching this, you must have really liked the video. Make sure you follow and subscribe, and check out these other videos that are even better. No, really. I've seen this one over 100 times.